All right, everyone, we're going to get started. It's 1 p.m. Eastern time. And so I wanted to start off before introducing our fabulous speaker for today with just a little bit of information for you all. So first of all, a big hello and welcome to the Carmeuse webinar, Caustic Soda versus Lime, Finding Cost Savings While Improving Safety, with our speaker, Matt Radiker. We appreciate you taking the time today to be with us, and we're very confident you'll find the information that's presented here informative and useful. I'm your host. My name is Mackenzie Ferrone. I'm the Manager of Marketing Communications for Carmeuse, and I'm going to go over just a few items prior to handing the information over to Matt to get started. So first, if you have any questions throughout this webinar, you can use the Q&A box that's available to you or the chat box. And we'll try our best at the end of the webinar, time permitting, to answer any questions that come up. All attendees will be muted for the duration of this webinar just to ensure that everyone is able to hear the information that's being presented. And finally, as you probably heard, there is a recording of this webinar being taken at this particular time. And we'll send that out via email to anyone who attended. So you don't have to worry about taking notes really or doing anything during this webinar. You will receive a recording that you can listen to at your leisure in your inbox in the next day or two. So I'm thrilled to announce our speaker, Matt Radiker. Matt is an environmental customer application specialist for Carmeuse and an expert in the use of quicklime and hydrated lime for water treatments and other industrial applications. As an experienced chemical engineer, he's well versed in everything from municipal water treatment all the way through to steel production. And we're so grateful to have someone with such a high level of expertise presenting to all of us today. And I know I look so much forward to this presentation and learning so much from you. So with that, I'm going to hand it over to you, Matt.
Well, thank you, Mackenzie, and thank you everybody for joining today. We're going to talk a little bit about, a topic near and dear to my heart, which is lime and lime slurry and how it compares to caustic. Here's the agenda, just to take a quick look. We're going to talk about some of the applications that are common to both lime products and caustic. We're going to look at some of the conversion considerations, including some physical differences between the products, and as well as storage-related, conversations of hardware and mixing and things of that nature. We'll get into really the meat of the topics as we get to safety considerations, cost comparisons, the differences in equipment and some of the, one of the producers that we like from STT that can service your needs, and then also finish up with a success story of caustic conversion to lime. So before we do any of that, though, what is lime? So I'm gonna save you our typical fruit jokes that we would have at this point and go straight into the products, which Carmeuse, in addition to some other things, produce quicklime, hydrated lime, and lime slurry. Quicklime is kind of the starting product, where we take calcium carbonate, which is mined out of the ground as limestone. We put it into a large kiln, which uses fuel to create heat. And in that process, we drive the CO2 away from the limestone and create quicklime, which is calcium oxide. We can then take that calcium oxide and hydrate it using a particular amount of water to satisfy the chemical requirements of that calcium oxide to produce a dry product that we call hydrated lime. This has about the consistency of like a baby powder, but and it actually contains water, chemically bound, but it is a dry product. And then finally, we also have lime slurry, which is going to be the bulk of the discussions today. Lime slurry can be produced either by taking hydrated lime and giving it excess water, or by starting with quicklime and then also using excess water with it in a process called slaking. So we're not going to talk too much about those conversions, but we'll come back around to these products here in a minute. So some of the common applications, we're just going to highlight a few. So lime is one of the most versatile commodity chemicals that are in existence. I mean, it goes into everything from water treatment to paper production to steel to flue gas desulfurization, construction, lots and lots of different applications. But for the applications where caustic and lime sort of intersect, that's going to be a little bit more narrow. And so we'll talk about some of the common applications between those two before we move on to the differences in the products. So the first one that I like to highlight is pH adjustment. So all the products, caustic and lime slurry, and then some other ones too. You see sodium carbonate and bicarbonate, magnesium hydroxide. These are all, basic chemicals. They are alkaline, so in every case, basically, if you take them and mix them with water, they will increase the pH of that water, kind of the opposite of acids, which reduce the pH, of course. For lime slurry, you can see the graph kind of on the right there. Whenever you get to slurry, this is a suspension of particles in water. This is well past the point of the sort of maximum solubility of calcium hydroxide itself. So this is a saturated solution, and it gives us a pH under, kind of room temperature ranges at about 12.45. So we'll come back a little bit later to talk about how 12.45 compares to caustic and some of the safety considerations. But the pH adjustment is sort of the most fundamental thing that we're going to do with caustic or lime slurry. Adjusting the pH higher allows us to do a variety of other chemical jobs, I would say. But at the most basic, we can neutralize acidic waters. So you'll see a lot of different markets for this kind of a thing. It could be anywhere from, drinking water, municipal wastewater, various industrial wastewaters attached to, say, steel plants or chemical plants. So moving on, another one that's very common is coagulation and flocculation. This is the removal of suspended solids. So, in the case of drinking water, for instance, natural water supplies have particles floating in them. Some of the larger particles are relatively easy to separate, either from, screening or filtration processes. But as you get to smaller and smaller particles, which are more and more difficult to remove from the water, sometimes they need a little bit of help. Coagulation and flocculation is a process where we take chemical coagulants. There's a wide variety of them. I have two called out here. Alum sulfate, ferric chloride, those are very common ones. But there's a wide variety of inorganic and organic coagulants that exist. All the same, lime and caustic can be used as an aid for these. By adjusting the pH to an optimum level for these coagulants, they can actually make the coagulants work more efficiently and therefore more cheaply. What these things do is actually basically neutralize the charge on these tiny little suspended particles. Sometimes we use the term turbidity to discuss these sort of suspended particles. And by neutralizing the charge, we allow these particles to clump together into larger clusters, which are then easier to filter or clarify out of the water. Our third one that we'll discuss is lime softening. So in this particular case, we are looking to control the hardness levels in water. Again, natural water supplies, particularly underground supplies, which are very common in sort of the middle of the country in particular, and a few other places like Florida. Those natural water sources often contain hardness in the form of magnesium and calcium bicarbonates. This hardness can be difficult to remove, except for a few different processes like using lime softening. If you don't use lime softening, then typically what happens is that hard water will deposit scales in various places, such as your faucets and your dishes, or in the distribution pipelines for water itself, which over time can cause significant issues with distribution of water sources. So in the case of lime softening, it seems a little strange, but we actually use calcium and magnesium products to control calcium and magnesium materials that are actually in the natural water sources. It's a little outside of the scope of this conversation to explain exactly how that works, but I'd love to have that conversation if anybody's interested, offline of this. And then the fourth is dissolved impurities removal. So there's a variety of dissolved impurities that we could talk about, but as a point of reference, we can talk about metals here. So different metals are actually have a variable solubility that is strongly based on the pH of the water that they're dissolved in. Highly acidic waters have a very strong capacity to dissolve a very large amount of metals in them. And the chart on the right, or the graph rather on the right, kind of shows a number of different metals and how much capacity for dissolution of those metals can exist in water at different pHs. Now, if you're logging into this on a very small screen, it might be difficult to see the vertical axis. But that is a logarithmic scale, so every sort of notch that you move up on the Y scale, you actually have 10 times as much capacity to solubilize a metal. You could probably see if you look at it for a little while, though, that many of the metals have sort of a lowest solubility point. A lot of those kind of fall into that sort of 9 to 11 pH range. So basically the idea is that if you have a water that is typically acidic, that has dissolved metals in it that you need to remove, say, before you release the water back into the environment, in order to do so safely, you can take products like caustic or slurry, add them to the wastewater to neutralize the acids, and then eventually move the pH high enough into the most optimum range for your particular wastewater in order to cause the metals to fall out of solution, and then you can simply filter or clarify them away. At the end of this process, you'll have a much safer and more healthy water for the environment and anybody else that would be in contact with it. So there's a wide variety of other applications, but that kind of gives you a flavor for the sorts of things that we're looking at here whenever we're comparing and contrasting caustic and lime. So next up, we can talk about some differences in terms of physical characteristics, pH and solubilities, and reaction products that are formed. This will give you a sense for some of the things that you kind of need to watch out for when you do conversions from caustic to lime. Not every single process that exists is going to be a very good candidate for conversion from caustic to lime. And understanding these differences can help you understand why not all are going to be good candidates. So back to the lime products that Carmeuse produces. I want to show this slide again that's slightly tweaked because I want to mention one thing. Most of the applications that use lime products that are common with caustic will integrate the lime into the customer's process in its liquid form. So regardless of if a customer is in a position where quicklime or hydrated lime would be actually more economically feasible for them, they will still, if they're using one of those dry products, use equipment that is designed to safely and efficiently convert their dry product into lime slurry. So at the end of the day, even though Carmeuse produces and sells all three of these products, at the end for these particular processes, the customers are almost always going to convert any dry products into the slurry anyway. So why would you use one product over the other? There's basically two factors, right? So quicklime, in order to convert it into lime slurry, has a process called slaking. It's an exothermic process. It produces heat and steam and things of that nature. And in order to do so safely and efficiently, you need the most expensive equipment out of the equipment that is required for each of these products. And these are called slaking systems. Slaking systems have dry handling systems, storage systems rather, in terms typically of silos, feed systems, controls, equipment necessary to handle the exothermic reaction and steam in a safe manner. And as a result, that has kind of the highest capital cost equipment. But the balancing factor there is that quicklime tends to be the lowest reagent cost. Quicklime has the least processing steps to get it to the point where it's usable for the customer. And also, whenever you ship it, there is no water chemically combined with quicklime, as is the case for hydrated lime and lime slurry. So you have to, and then as we move to lime slurry, it's the very opposite, right? So lime slurry will take a look at what the equipment is necessary for lime slurry, but as a preview, it's basically going to be a mixed tank. So we're looking at low capital cost of investment for just the lime slurry system, but at the same time, you're looking at a product that is the most processed, and also it comes with 60 to 78% of the weight of the material as water. So when you ship water, of course, that's an expensive proposition on a per ton basis. So you kind of have this factor as in terms of capital cost or reagent cost between these three products that you want to balance, hydrate kind of being in the middle. And so for some customers, especially like smaller volume customers, lime slurry tends to make the most sense. For larger customers, quicklime does, but in any case, you're going to convert to lime slurry. So again, taking a look at this, we have our solid products, quicklime and hydrated lime. From this point forward, we kind of discussed a little bit about what you're going to do, but because in this particular presentation, we're going to only talk about the liquid products from this point forward. We're going to kind of put aside these solid products until the very end of the presentation at this point, and really just focus on our two liquid products, which are the lime slurry and the caustic. So the physical characteristics here between the two, lime slurry is just that. It's a slurry, which means it's a suspension of solid particles in water. These solid particles are clusters of calcium hydroxide. These are very, very small. They're typically measured if you took a particle size analysis of them in terms of single-digit micron sizes or even sometimes sub-micron sizes, so very, very small. The solids concentrations typically are found, at least for ready-made slurries, in the 25 to even sometimes 50% by weight solids concentrations. Most of the commercially available slurries are kind of more toward the middle, toward the like 35 to 40 range, but 25 to 50 is what can be seen in the US and parts of Europe. And the availability of those percentages is typically a regional thing. So any slurry producer, the vast majority of them just kind of have one or maybe two slurry grades available at any individual location. If your particular process needs a slurry that is slightly more thin than the slurry that's available to you, dilution of slurry is very, very simple just by adding a calculated amount of water to the slurry. In the case of caustic, we're not dealing with a suspension, we're dealing with a true solution. So this is sodium hydroxide actually dissolved in water. There's basically three major versions of the product that are commercially available. There's a 50% solution, that's kind of the most common. 20% solution is also fairly common, and particularly whenever you get into the northern colder territories, you're going to see 20% more and more. We'll talk about that. It largely has to do with the factor of freezing, but there's some other things that go into it. And also it's a little bit more of a niche product as far as I've seen, but there is solid flaked versions of caustic that are available in some places as well. In terms of pH and solubility, lime slurry, as we mentioned before, typically goes into about the 12.45 pH range. That is somewhat temperature dependent. So 12.45 is the pH range that you would see at about 25 degrees Celsius, call it room temperature. As lime slurry gets colder, that pH is actually capable of rising a little bit, but it is always lower than caustic, which is 14. So the pH range, if you can recall back to chemistry, is actually on a logarithmic scale. So each time that number goes up, the actual concentration of hydroxides that is available for reaction is significantly larger, even though the number doesn't really seem to change very much. And as a result of that, lime slurry, and we'll come back to this in the safety portion, is only considered mildly hazardous, generally speaking, whereas caustic is almost always considered universally highly hazardous. But on the balancing act, the poor solubility of lime slurry is going to require that we're going to have constant mixing. We'll talk about that shortly, whereas caustic soda is extremely soluble. It doesn't need constant mixing. It's fairly easy to handle and pump. Taking a look at the equipment, this is just examples of some of the different storage vessels that you might have. In the case of caustic, the storage vessels, they may need some heating, but other than that, they're relatively simple. There's not a lot going on inside. Lime slurry tanks, by comparison, you need to be almost constantly agitated. And also we recommend baffles in order to maintain the proper agitation. So in the case of lime slurry, because it's a suspension of particles, those particles will settle if there isn't agitation. Now, it isn't immediate though. So if you, for instance, have some kind of outage or need to do maintenance on your mixers, if they're only down for a couple of hours, you'll notice a little bit of settling with the lime slurry, but it's not going to be extensive. And typically it's very easy, over those couple of hours to just kick the mixer back on and you're back in business. However, if there's some kind of a longer term outage and you need to have the mixers down for maybe a couple of days, that gets to be a little bit more tricky. Most slurries will settle pretty substantially within a couple of days, and the mixers themselves may not be enough to re-agitate that settled slurry. So we can always help you with that. Anytime you go into an outage, there's some best practices in terms of how to prepare yourself and what to prepare in order to be able to get any kind of slurries resuspended. But that is, a major differentiation point. For some other physical characteristics, we can look at the freezing point. As mentioned before, caustic actually has a very strange property, at least strange to the common person who is so used to things freezing in the case of water at 32 degrees Fahrenheit. 50% caustic, believe it or not, can start to freeze at 60 degrees Fahrenheit. So that kind of matters. I mean, 60 degrees Fahrenheit, most of North America hits that at least some point during the year. So anytime you're storing caustic, you need to either do one of two things. One, you can heat it to make sure that it always stays at or above 60 degrees Fahrenheit. Or if you have a large enough storage tank, you can potentially dilute it down to lower concentrations that actually have a suppressed freezing point that approaches, the kind of normal freezing point of water. Lime slurry, on the other hand, it just freezes at 32 degrees Fahrenheit. But it's also important to note that lime slurry itself has a fairly high heat capacity. So it does take a while to even get down to 32. If you're using your slurry at a relatively, decent rate, usually freezing isn't really a major issue for most customers, unless they're in the far north of Canada. I'm sure there's folks that'll tell me of all the problems that they've had, when the temperatures hit negative 20 degrees Celsius or whatever. But for the most of us, this is usually not a major issue. Now, probably the biggest difference whenever you're considering changing from caustic to lime is actually going to be the reaction products. And what I mean by that is that when you're neutralizing acidic waters, you can sometimes form solids whenever you're switching to lime slurry. Not always. I have a couple of examples down there. So if you actually take lime slurry and neutralize a water that has a low pH as a result of hydrochloric acid, typically you have little to no solids that are formed under those circumstances, regardless of whether you use lime slurry or caustic soda. However, if an acidic water is acidic because it contains sulfuric acid, that's a little bit of a different story. So in the case of caustic soda, the reaction product in that particular case with sulfuric acid, is sodium sulfate, which is still fairly soluble. A lot of times if you do that neutralization reaction, there's very few solids that are generated. But if you try to switch to lime slurry, lime and sulfuric acid actually create gypsum, or chemicals very similar to gypsum. And these chemicals are basically all more or less insoluble. So in making a switch in that particular case from caustic to lime, you may find that there's significant solids formed. These solids, of course, need to be dealt with in some way, shape, or form. There's a couple of processes like filters, for instance, or clarification. If your process that currently uses caustic soda has these downstream of the introduction point of caustic, then you may still be okay to switch to lime slurry, but we need to understand what the increased solids generated might be to make sure that you aren't working yourself toward overrating your equipment. Here at Carmeuse, we have what we call the Innovation Center, which is a lab and research and development center located in Pittsburgh, Pennsylvania. And we've got lots of folks that have done this kind of relatively simple testing for many, many years, as well as much more complicated testing. We're happy to help you long before we ever get to on-site testing, do lab scale analysis of this kind of a thing to answer the question as to what kind of increased solids that you might expect. That way, if it's just a non-starter, you can find out right up front, and nobody has to waste any time moving forward. And now, without waiting any longer to bury the lead, we'll talk about some safety considerations and things like that. I mean, at this point, you're probably wondering what kind of presentation this is, because at this point, the guy that is advocating for lime slurry has almost entirely talked about the virtues of caustic, but this is where we're actually going to start to get into the major considerations that make lime slurry make a lot of sense versus caustic, and the first one being safety. So in the case of caustic soda versus lime slurry, both of these two chemicals are considered to be immediately corrosive to eyes and mucous membranes. That's going to have some implications in terms of the controls and equipment that you use, and as well as the PPE. We'll talk about the PPE shortly. But where we start to really separate ourselves here is in terms of just general skin contact. Caustic soda being pH 14 is immediately corrosive to skin. Chemical burns happen basically instantaneously, and so you need to be very cautious about making sure that you don't contact any skin on your body with caustic at all. Whereas lime slurry, it's generally just a skin irritant. I've worked with lime slurry now for approaching 7 years at this point. And I've had slurry on my fingers and things like that plenty of times. As long as you don't go hours on end of leaving it on there, Usually you can just wash it right off and there's no problem. Your skin might be a little dry, but it certainly isn't significantly damaged like what would happen with caustic soda. Also, caustic soda is going to react strongly with both acids and water. You have to be very careful about dilution of caustic. Typically, you want to make sure that humans aren't involved in that at all and everything's automated because, you know, in the case of diluting caustic soda, there's going to be a strong reaction when that happens, a lot of splash, things of that nature. In the case of lime slurry, dilution is nothing. You can add water basically all willy-nilly to the lime slurry without any issues. Lime slurry does, however, still react strongly with concentrated acids. So in that case, if there's, for some reason, you know, an application where you'd add lime slurry directly to a concentrated acid, you'd still want to try to automate that as much as possible. In the case of PPE, for eye protection, no matter which of these two that you're looking at, we recommend that you avoid wearing contacts. That's a general rule in chemistry and for any time you're dealing with liquids, I'd say, that are potentially hazardous to your eyes, just because contacts can actually trap chemicals between the eye and the contact and make it much more difficult to wash them out if you get any contact. In the case of the PPE, though, typically with lime slurry, some safety glasses with side shields and chemical goggles are plenty sufficient for lime slurry. That's typically what I would bring to most customer facilities when I go on site for any kind of analysis of their system. But in the case of caustic, because even the bare skin on your face is potentially susceptible to damage, caustic, you're almost always recommended to have chemical goggles, face shields, the whole 9 yards to make sure that nothing can come in contact. Similarly with skin protection, with slurry, with lime slurry, just long sleeved clothes are recommended, long pants, long sleeved shirts and things like that, just to kind of keep it off your skin. But again, it's not the end of the world if you get a little slurry on your arm or something. Just make sure that, you know, you wash it off in a reasonable amount of time. By contrast with caustic, you can see the gentleman over there wearing full body chemical resistant clothing from head to toe. This is standard practice when dealing with high concentrations of caustic because it's just immediately corrosive to your skin. In the case of first aid for eye exposure, in both cases, if you get any caustic or lime slurry in your eyes, you want to flush with water. If you actually look at the SDSs for the two products, lime slurry recommends about 15 minutes of constant exposure to flush water, holding your eyes open, and then seeking medical attention, whereas caustic recommends 30 minutes before you seek medical attention. Additionally, for skin exposure, as we mentioned, you know, if you get lime on your skin, just wash it with excess water. If you see any kinds of, you know, redness or something on there that gives you problems over time, you may seek medical attention, but short-term exposure to lime slurry rarely causes injury. In the case of caustic soda, it's recommended to wash the skin for at least 30 minutes and then seek medical attention because chemical burns are almost certain. So for the second part of the benefits of slurry over caustic, we can talk about the cost savings. So we'll take a look at comparison of our product here at Carmeuse. Our branded product for lime slurry is called Calsafe. We'll take a look at lime slurry and caustic soda and kind of compare and contrast some of the cost considerations. We can take a look at the payback after investment, so just one quick analysis of it, and then we'll move on to kind of some of the final topics. So again, Calsafe, this is Carmeuse's branded product in North America. We have it available at four different locations. There's a 30% solid slurry as weight calcium hydroxide in the Boston area. We have two other locations in Chicago and Baltimore that have roughly 40% solid slurries available. And also up in Blind River, Ontario, we have a 25% solid slurry available. So taking a look at the differences in terms of cost, we're going to look at it in a second, but more potent pound for pound than caustic slurry is. It's going to be cheaper on a pound for pound basis than caustic as well. We just talked about that, it's the fact that it's safer than caustic. And for any of the folks that are treating waters that don't generate significant solids, or folks that have equipment that is capable of handling the additional solids, Calsafe is a strong, should be considered as a strong candidate for your particular process because of the safety and cost considerations. So a quick scenario. Let's say a customer in the industrial wastewater treatment industry is being challenged to find a 10% reduction in their spending. So they currently use caustic soda, but they wonder if there's an alternative. So if we take a look, I have some prices here. None of this is a guarantee of pricing or anything like that. These are just nice round numbers that are kind of ballparked to relatively recent cost structures for both Calsafe and caustic soda. Of course, for your individual pricing, we can get you in contact with your salesperson. So don't take these numbers as gospel or anything. These are just something that are nice and rounded in order to be able to easily do some math. Calsafe, you're usually looking at products in the $300 per dry ton range as calcium oxide. Caustic soda, on the other hand, using data from 2019, I believe this was, they were looking at an average of about 500 dry tons, which fluctuates significantly over the year. $200 swings either way, that kind of ride along with the changes in construction seasonally. Caustic soda is actually a byproduct of the production of chlorine gas, actually, which then goes into PVC production, which is why those two things are connected. Calsafe, on the other hand, we make lime all year, we make Calsafe all year. Everything's consistent. It's not dependent on any other kind of industry. So the cost volatility is very, very low for Calsafe as compared to caustic soda. In terms of potency, from a theoretical basis, every 1 ton of dry calcium oxide in the form of quicklime is roughly chemically equivalent to about 1.3 tons of dry sodium hydroxide. So whenever you take the difference in the cost per dry ton, as well as the difference in the potency per dry ton, you get a rough relative cost basis of $2.17 for an equivalent amount of caustic for every $1 of Calsafe. So this is a big difference, obviously, and this is where kind of the lights should be flashing and the eyes should be perking up if the safety didn't get you going there first. So if we take just an example account, in this particular case, I'm using 500-ton calcium oxide account. That's roughly equivalent, again, because of the difference in potency, to a customer that might use about 650 tons of sodium hydroxide. You can kind of take a look at what we have in terms of a little bit of a very simplified payback analysis. So again, that $1 per dry ton of Calsafe to $2.17 per dry ton of, for every $1 you'd spend on Calsafe, you'd spend $2.17 on caustic soda. Now, in the case of switching from caustic soda to Calsafe, there's a pretty good chance that you're going to need to install a slurry tank. Again, we mentioned that the slurry tanks are going to be a little different than what you may have on site already for the caustic soda. So the actual prices of these particular capital systems, obviously depend on things like the actual size of the system that you want, the bells and whistles that would go along with it. But for sort of like a pretty minimalistic tank that we would recommend for installation, $175,000 might be the kind of capital that you'd look at to get started with this kind of a transition. Might be slightly higher right now just because the steel prices are, of course, pretty high. But, that kind of gives you a ballpark idea of what you're looking at. But it doesn't take very long to pay that off whenever you're able to reduce the, ongoing reagent costs of the process by over half. So in this particular case, you're looking at something like a less than 1.5 year payback, and then, a pretty nice chunk of additional revenue after that at your 10-year mark. Now that assumes in that particular case that you don't need any additional solids removal. If you do need additional solids removal, then the number for capital is going to be significantly higher. So in this particular case, I have like $1 million put in there. This number is pretty variable depending on what you can get away with, right? So filters are one thing, but if you need to install a large size clarifier, there could be a lot that goes into that, right? I mean, it's a large concrete tank, but it takes up a lot of space. If you have space available, that's great. But if you don't, then that can potentially be, a pretty big cost structure. And so in that particular case, if you just sort of assume $1 million, if that's the number that works out in your particular case, you still end up with a payback. It's just not nearly as, attractive in that particular case. But nevertheless, there's a lot of circumstances, even when you might need to install solids removal, that it still makes sense to you to make the switch. So equipment considerations. this is where I take a second to kind of pitch Carmeuse and our sister company STT. So between the two, we have everything under one roof basically to help you out. So Carmeuse is the wing of the company that produces our calcium reagents. Again, that's quicklime, that's hydrated lime, that's Calsafe. Additionally, we have freight services available for those products. And our sister company, STT, which is Storage and Transfer Technologies, based out of Ontario, Canada, they actually will engineer, design, build, install, commission, train on all kinds of different equipment options. For quicklime, there's dry slaking systems, mixed tanks, pump skids, all sorts of different equipment solutions related to calcium reagents and Calsafe. So between the two of us, peace of mind under one umbrella. But before you go buying any large scale equipment, we mentioned earlier that there's probably a phase in which you want to do some lab scale testing in order to understand any solids generation, in order to understand if that ratio of 1 ton of lime to 1.3 tons of sodium hydroxide is the specific ratio for your wastewater. Our Innovation Center in Pittsburgh can help you understand those things on a lab scale basis. But before you start investing hundreds of thousands of dollars in capital, we also have solutions to do full-scale on-site trials as well. We have 2 different systems that are available to us. For smaller systems, we have a tote battery system. Now, these are simple chemical totes. We can have as many of them as is necessary for your particular application and for the length of trial that you need. But each tote is about a 300-gallon tote. We can sort of fine-tune the number of totes that we need for the slurry trial length and volume that's necessary for your process. Additionally, we have a portable mixed tank available as well. So this mixed tank is a 9,700-gallon tank. It's got a lot more bells and whistles in terms of controls and whatnot. So this requires a lot less manpower, and it has a lot more volume. So it's a lot easier to have longer trials or higher volume trials while needing less manpower to do so. So this is a great opportunity. This is a great trial option for longer term trials. And additionally, if you have any kind of situations in which you may need temporary storage solutions for, say, an outage or something, this unit is also available for rent as well. Additionally, STT, as mentioned, has permanent solutions as well. So mixed tanks, pump skids, dry quicklime and hydrate systems as well. What they don't get into at this time are the solids handling systems that you may require, as mentioned. So clarifiers, filters, things of that nature. STT doesn't have those on offering right now, but certainly I think Carmeuse can work with you and third-party, clarifier or filter manufacturers in order to be able to work through your needs if that is determined to be the direction that you want to go. And finally, before we get into questions, and I'm moving a little faster than I had before, so it looks like we'll have lots of time for questions, but quick success story. This was back a number of years ago, a drinking water treatment plant in Washington, D.C. Had a little snippet. So Al, who was an engineer at WSSC, really led the charge to a particular situation where they were switching from caustic to Calsafe. So the main reason they wanted to use slurry or caustic was for pH control at this plant. And the price of slurry was basically 50 to 60% lower than caustic. So that kind of falls in line with the price considerations that we looked at earlier. So in this particular case, DC at that time installed a small trial tank of about 5,000 gallons for 6 months to prove out the science. And they were so happy with the results that they actually justified putting in $800,000 of capital in the form of 2 10,000-gallon tanks with agitation right at the site for a permanent solution to dose at Calsafe. So, in their particular case, it was a lot higher in terms of capital, but they were looking at, double tanks and a larger volume of tank than is necessary for all operations. But nevertheless, they saw so much savings and so much potential in this particular switch that they easily justified the better part of $1 million worth of capital investment. That customer still takes Calsafe today. And I don't know if you're on now, Dan, but I thought I heard that you were on the list for this. So Dan Fitzpatrick, former general manager of the Chemline facilities here, appreciate you getting this success story for us back in the day. And if you are on, hope you enjoy retirement. So with that, I moved a little faster, so we've got plenty of time for questions. And at this point, I think I will allow Mackenzie to pop back in and see what, if any, questions that we have available. Thanks.
Yeah, absolutely. And so we'll leave a couple of minutes for people to type any questions if they have them. Again, in the Q&A box or the chat feature, either one is totally fine, and we can present those to Matt. But as you are doing that, I did want to just say thank you so much, Matt, for that presentation. I think that it was really informative for me, being new to Carmeuse, and this is a new industry for me as well. It was beneficial to learn. And I can't imagine how beneficial it is, even more so for those in these areas. So I think that was wonderful. So there was one question that came through. So what would you say if there's someone that's currently using Caustic and they're thinking about the switch to lime? So maybe this presentation made them start turning their wheels a little bit and thinking more about whether or not it's right for them to make the switch. What do you think would be one of the top 1 or 2 things to consider if they're on the fence about making the switch between the two?
Yeah, so I mean, again, you have to compare and contrast the differences. You have your big pros in terms of the switch for cost savings and safety savings. But in order to determine whether or not you should move forward with it, again, you're going to need to understand at least 2 fundamental things, which is, are you going to generate additional solids, and what actually is the proposed cost savings? In both cases, like I mentioned at our Innovation Center here in Pittsburgh, what we can do is we can set up a couple of calls to discuss the equipment that you have in place, what you're trying to achieve with the switch. And what we would typically do in these cases, and what we have done in the past, is grab water samples of the proposed water to be treated, have those brought to the Innovation Center so that we can do a comparative analysis of caustic, whatever particular product that you're using right now, versus the sort of regionally available Calsafe that you have. And we'll actually do the lab scale analysis to tell you, this is how much extra solids you're going to generate. And we can work together to understand, okay, so can you handle those extra solids, or are you going to need to install equipment for that? Also, is the ratio of 1 to 1.3 dry tons of lime to caustic the actual ratio that's going to work in your particular wastewater? Sometimes it's a little different than that ratio, but that's kind of the base cases. And we can answer all those questions. That way, before you ever work on a on-site full-scale trial, you actually have some understanding as to what the potential is here. Are you going to potentially have to look into installing equipment, in terms of solids generation, or is it just going to be a simple, relatively small slurry tank that can be installed for a relatively quick payback? So, at the end of the day, probably the biggest driver for a lot of people is the cost difference. But again, safety is on everybody's minds, and it's only going to be a bigger and bigger concern. So.
Sure, absolutely. And I would say that probably safety is definitely something that you want to consider before it's brought to your attention, and not after you have an unfortunate incident of some kind. So always good to keep that top of mind. And when we're talking about doing a trial or sending some of that information to our Innovation Center to take a look and help determine whether or not it's something they want to move to, how do they start that process? So how would they contact us or get into contact with the right people to start something like a lime slurry trial?
Yep, and so I believe after this presentation, so in addition to everybody getting a link to the presentation itself, we'll also have contact information within those emails in order to get you in touch with the right people, whether it be somebody like myself to get the process started in terms of the right technical questions. If you're long past the technical portion and we're straight on to just talking price, we can get you in touch with the sales folks. Or, again, if it's an equipment concern that we would need to look at, we can get you in touch with the smartest folks that we have there at STT. So, all of that contact information, whatever it is, we should be able to I think, distribute that here in the follow-up emails.
Yeah, absolutely. And that is one of the things that I think is really great about not only this offering, but across the board, right? Between Carmeuse and STT, we have expertise, from end to end, raw materials, freight and transportation, all the way to the applications and the systems. So we can really help in any part of that process. We have those experts, which is, I think, really unique to us. So I think that's all the questions that came through. And just to kind of piggyback real quick on your answer to the last question, Matt. So for all of the attendees today, like Matt mentioned, you will be receiving an email with the recording. There's going to be a couple of other points in there that I'm going to gently ask that you please interact with. One is a survey, very short. It'll only take a few minutes to complete, but it's going to be questions about your experience on the webinar today, just to let us know your thoughts and how we can continue to improve the webinars that we offer, and also asking for additional topics that you might find value in learning about that we can create a program around in the future. The other that we are going to ask is just to let us know if you want to speak any further, to Matt's point, to an expert about any part of this process. We have a lot of materials and white papers, articles, things along those lines that have to do with lime slurry trials and Calsafe and the switch from caustic soda to lime. So we can provide a lot of additional information as well as this recording to everyone. So please keep an eye out for those things in your inbox. Again, thank you so much for taking some time out this afternoon to spend with us and learn about this topic. Matt, thank you so much again for your expertise. And we hope that everyone has a wonderful day. If there's any questions at all, feel free to reach out to us. And other than that, we hope you have a great remainder of your day. Thanks, everyone.